Hi everyone, hope you are doing fine. So today I am going to solve the today contest of the lead code. So the contest is live. So yeah, I just registered and so let's join the contest. It's already started. So you can see the time is 8:01 p.m. So yeah, let's wait for opening the contest. Why it is not opening? So why it is showing me register again? So yeah, I think that the error is from lead code side. So let's again join the contest. It is not working. Let's wait for a minute. Is it is working or not? Let's see. So let's open all the problems and see if anyone opens. Again, open the first problem. Yeah, so it's working now. So the first problem is like a unique middle element. You are given integer array nums of odd length and return true if the middle element of nums appear exactly once in an array, otherwise false. So yeah, it's a pretty simple problem, or you can say like it's a very easy. So in this problem, we have something like array of like array is of odd length, and we have to return true if the middle element of the nums appear exactly once in an array. So yeah, so you can see the nums value is very less, like 100. So we can maintain like a array of the 100, and we can so let's write the code for this. We can make it as a DP, and we can do it as 101 comma 0, and we are going to iterate the nums array and increase its value. Yeah, so now we check if the DP of v of and divide by 2, uh, like uh and is going to be a nums dot size. Let's make yeah. So now we check if the num if the DP of nums of mid value is equal to 1, it means that yeah, it's present single time, we can return true, else we can return false. So let's try to run this. First one is true and the second one is, so let's try to submit this out. Let's read the second problem. So maximum valid pair sum. So you are a given integer array nums of length and an integer k. A pair of indices I and j is called valid if the like I must be less than j, and j must be less than n, and j minus I must be greater than equal to k. Return the maximum value of nums I comma j among all the pairs. Yeah, first one is submitted. So let's try now second. So in this we have something like given like a array of nums and an integer k and a pair of indices I and j is called valid. Like if the I and j like I and j must not equal, else we can take 2 point I and j, and a j minus I must be greater than k, and we have to return the maximum value of nums of I plus nums of j among all the valid. So so it's a pretty easy problem. So yeah, let's try to. So yeah, let's try to. I think so. Firstly, I can write the code for this, so that can finish the contest earlier. So we are going to take this like a size, and then we are going to traverse from n minus 1, I greater than equal to 0, and I minus mine. So we are like you can see like we have to maximize this num of I and a j. So we can try for all the nums of I, and from the left from the right side we are going to from right we have to get the maximum value which we can achieve after this this jth index, including that jth index. So for right part we can simply maintain a prefix sum. So yeah, so we can say like make it as a dp only, uh a name of a vector, and it is going to be n comma, we can assign it as a 0. Like if I equal to n minus 1, then value is going to be a dp of, oh sorry, v of n minus 1. uh, uh, in else case it is going to be a like I have to assign this also to n minus 1, else dp of I is going to be a dp of I is going to be a mean like we have to do maximum of v of I comma dp of I plus 1. So yeah, we are making make this some like the thing we have in our like maximum we can get from the like if we are taking this much from what is the maximum from this thing, so which is stored from in the last index. So yeah, we have to do now we have to do something like move from I equal to n for every thing we are for every index we are checking. So I minus j must be greater than equal to k. So in this case j is going to be I plus k. So yeah, like if we add I plus k to I, then the difference minus j minus I is equal to k. So yeah, so we now we check if j is less than j is greater than or equal to n. So we can simply return we can simply break, and else we can say like let's define the answer equal to 0. Yeah, like answer can be like oh you we 10 is power 9, so it come in trade. Yeah. So now let's define a temp answer. Temp answer is going to be a v of I plus dp of j. So yeah, so answer is going to be a max of answer comma temp answer. So yeah, so let's run this. So I think is there an active value possible? No, negative values are not possible. So let's see. Any syntax errors or like we are doing from, yeah. So for we are getting 13 and 14. So let's try to submit this. I hope it should work. Yeah, it is working. So let's move to the third problem. Uh, minimum operation to transform binary string. So you are given two binary string s1 and s2 of length n, and you can perform the following operation on s any number of time in any order. So we can choose an index I such that s of I is 0 and change is to 1. We have something like s1 and s2. First is like we can only perform operation on s1, change s of I value from 0 to 1, and choose an index I must be less than n minus 1 also. Oh yeah. So and both s of I and sy are 1, change both characters to 0. Like if two like So it means that from we can change like any 0 to any 0 to 1, and if there are two 1 two continuous 1, we can mark them as 0 0 also. So yeah, so we have to return the minimum number of operation required to make s1 equal to s2. If it is impossible to make s1 and s2 equal, then return -1, else you can return the minimum number of operation. So yeah, so let's see what are the different things which are possible. So like we can perform this type of operation. So let's take example and try to figure out what are the possible ways in which we can transform this thing. So if we have something like 0 0 1 0 0 0 1 and all are 0. So if the all the value are 0, we can simply like we can simply take like as 1 in as 1 and simply transform also. Sorry, so we can't transfer 1 to 0, we can only transfer like 0 to 1 and from 1 to 0. So like so yeah, we have something like a string like this. So let's say another example like something like this 0 0 0. Yeah, here is 1 1 1 1, and we have something like 0 0 0 0 0 0 0 0. So in this like we can simply like you can see like first operation is like we can change 0 to 1. So we can simply change let's sorry, like in s2 this all are 1, so let's say it's all are 1. So we can simply take 0 and make this 1, take this 0 make it 1, and for all. So in that case the answer is going to be a number of zeros. Yeah, but like in this case you can see we can't convert 1 to 0, we can only convert 2 1 to zeros. So instead of doing that, what we can do, we can simply make like if we are starting from the right part, let's say we are starting from the end side, like this side, and side we check like if it is a 1, okay, but we have to make it to a 0, no problem. What we can do, we can simply transform this to 1, and if we transform this to 1, it's next to the 1, we can make both at 0, like we can make this both to a 0. So like firstly we have to track like if the previous value like if it is a 1, we have to check like its previous value. If its previous value is 1, we can simply transform to 0 0 to match this thing. So now when we move to this thing, let's say in this case it is going to be a 0 0 because what becomes 0. So the number of steps is going to be a 2, because firstly because it was 0, we convert this 0 to a 1, and then again this 1 to a 0. So yeah, so again like these are matched again. Look, these values are not matched, but we can simply convert 0 to 1, so we can simply make this as 1. We can make this as 1. Now again these are matched. Now again we get something like a 1 here and a 0 here. So now we will check like again like for this the we get our answer, so no need to check in this part. So we again check the next part. Like next part the value 0, but we need like we need to make it 1 so that we can take to 1 and make 0. Again we add one thing like 2, like in this case we add 2 to our answer because one for converting 0 to 1 and another is like 1 1 to make 0 0. So yeah, in this case like I think it's also pretty easy problem, like 2 3 observation like is there any edge case. So like if we have something like 1 and we have to make it 0, so in this case like you can see like in this one we can't make it 0 because we need 2 1 to make two ones, and in by taking that we can make them to zero, so it is not possible in this case. So yeah, let's write the code for this also. So int n is going to be like s1 dot size. We can take s comma t, like I think that both the size length is same. Yeah, both string length is same. So first thing is like we are going to start from n minus 1, int I equal to n minus 1, I greater than equal to 0, and I minus minus. So we will check, like if if s of I is equal to, like if the what s of I and t of I values are same, then we have to do nothing, so we can simply continue the thing, continue. Yeah, else what we can do, like now else we have some condition, like if the s of I value is 0. So like if the s of I value is 0, we can simply change it to a 1. So we can mark s of I equal to 1, and we can increase our answer by plus 1. We can say, yeah, and initially answer is going to be 0. So we can simply add answer to a 1. So but another case is like if value is 1 and we have to make it 0. So in that case we will like we can't do directly, so we will check like if like is I is greater than 0, it means that there is a one previous value. So yeah, so in that case we will check like if the as like if for s of I minus 1 is going to be equal to 1. So in that case so like that value is 1, so we can like s of I and s of I minus 1 are both 1, so we can make them as 0, so we do answer plus equal to 1. So in else case we do answer plus equal to 2, but we don't need to change the value of si, because we are firstly marking it as like from if at s of I is 1, we are marking is going to 0, and then again we are converting it to 0. So no need for doing that. And all after that so s of I is going to become uh I think yeah, s of I is going to become 0, we can say, yeah. So like in this case if there is a value, but if there is there may be case that there was no value at like I, like if we have something like we can say we have something like this 0 0, yeah, and something like here is it's a 0 and it's a 1. So like you can say these both are matching, so when we move to this index there is no previous value, so that we can sorry, this is like this is going to be 1 and this is going to be 0. So there is no another value 1, so that we can take both and make this 0. So in that case we will check like if there is a previous value in like if there is a previous value, if it's already 1, we can make them make both as 0 0. So in that case this is going to become valid, but this is not going to become valid. So after that like it was something like this 1 0 0 0. So first so like this is s1, this is s2, so we are going to convert s1 from 1 0 to 1 1. So it's a first step, and then we are going to make both as 0 in second step. So we need two steps. So what happened if here was already 1, here was already 1? So in that case it was something like 1 1, then from 1 1 it gets converted to a 0 0, so this will match. And again we can convert any 0 to 1, so it becomes we can make in two step. So in both cases we require two step. So yeah, that's it. uh, like if else, we can check else if I plus 1 is like if I plus 1 less than n, it means that there is a value, and in else case it is not possible, so we can simply return -1 here. So if it is possible, then we can make s of I equal to 0, and we can add simply answer plus equal to 2, and at last we can simply return our answer. So let's try to run this thing. So we are getting output as 3 and output as 4 and output as -1. So yeah, let's debug. So like if both values are 1, in this case we are going to take this. So yeah, so in this case, like if s of I is 1 and we are adding like, so in this case the s of I minus 1 also becomes 0, and else like if it is not 1, it firstly becomes 0, and then again like firstly it we have to do 1 to make that thing. So if it's something like, let's say 0 here and 1 here, and yeah, so firstly we have to make this thing as 1, so it will become 1 1, and then we have to convert both to a 0, so it the value remains same, and but the count become increased by 2. So yeah, let's now try to run this. So first case we are getting 1, and second case we are getting 3. So I think I have missed one edge case, like t- let's try to like 0 1 1 0, 0 1 1 0, 0 1 1 0. So like these values are different, like it's s1 and s2. So s1 become s1 is from 0 1, so it will change to something like 1 will change to 0. So yeah, we can so we can't change 1 to 0, so we will take the help of next one. So we will mark this as 1, so it become 1 1 in first step, and in second step it become like something like 0 comma 0, so first match is, and in and from 0 to 1 we can convert it in 1, so like it is going to take 3 step. So why it is showing us a 4 step, like let's debug this thing. So yeah, like if s of I is equal to 1, like if it is equal to 1, then in first step we make yeah, so we don't need to convert this into a, so yeah, like in this case it was something like 1 1, I think, yeah, it was previously 1. So if s of I equal, then s of I is going to be a 0, do nothing. If s of I is equal to 1, So it is a 0 1 1 0. 0 1 1 0. So it's 0. So we convert this to 1 1. It become 1 1. And then after 1 1, it convert to a 0 in two step. 0 0 in two step. Then we have 0. Yeah, we can simply do. But why let's again try to run this thing and see. We are getting 1 for this, but 2 for this now. So yeah, if s of I is equal to 1, then it's going to be a, so it's going to be a string like some, yeah. So like in this case, in both the cases we need to add 2, so I think we can skip this thing. 1 0 1 3 minus. So let's try to submit this thing, or we have missed. Oh yeah, so it is working fine. So let's move to the fourth problem. So like after solving like fourth problem, I will come back to the all the problems and try to explain what was my like how I approach the problem, like how I will explain the whole code. So the problem fourth is count distinct ways to form target from two string. So you are given three string, word one, word two, and the target, and your task is to count the number of ways to form target by choosing characters from word one and word two under the following condition. For each character of target, choose one matching character from either word one or word two. The chooses indexes from word one must be strictly increasing, and word two also must be strictly increasing. At least one character must be chosen from both word one and the word two. Two ways are considered different if at least one position in target the chosen characters come from different string or different index. Return the number of ways. So yeah. So let's take this example only. And so yeah, so we have something like A, B, and C, and another second string is B, A, C, and the third one is the target is A, B, C. So yeah, so now we have to make the target as ABC. This is our target, we can say. This is first second string T, and this is one S. So we are making word 1 to S and word 2 T. So now, so let's see what are the constraints of the problem. So so the constraints are like quite low, like hundreds only. So so what we can do, we can try to make like all the valid combination, like so now like we will add like we will add indices, this index, like we can say this is I, and this is going to be a J, and this is going to be a K. And we can make two variable like as like C1 comma C2. Initially both are going to be false, yeah, both are going to be false. And by this it means that if false, it means that we haven't if c1 is true, it means that we have choose one, at least one character from s. And if c2 is true, it means that we have choose at least one character from t. So now, yeah, we at our acid at I and t is at j, and k for t we are at k, like first index. So now we can compare, like we have two ways, like whether s of I is going to equal to t of I. This is the first case. And another case is like oh, sorry, yeah, so we can make it as a, like this is a small t, so this yeah, we can make it as a complete target, st and a target. So like if s of I comma target of k is going to be equal, this is the first case. And the second case is like, let's make it to a full screen. Second case is like t of I is going to equal to a target of k. And third case is going to be like something like both are not equals. So we can skip both case, like s of I is not equal to target of k, and this is going to t of j, and t of j is also not equal to target of, we can say something like target of k. So like these are the four cases, like if the like one or we can say like combination of these. So like we now we have option, like whether we can choose for one, like we can choose this thing. If equal, we can choose, like if the value are equal, we have two options, we can choose or we can skip this. So like we cannot choose this thing. So this is the first case. And for another, like if t of like another let's say for this also we have something like choose and not choose. But like if the values are not equal, we have only one option, like we can't choose this thing, not choose. And in this case also we have not choose option. So yeah, so like by forming, like by uh, forming this thing, this thing is converted to a simple, like a, we can say choose not choose dp state. So like this is a very classic dp, we can say dp pattern. So by doing this we can simply try to make all the possible combination, whether it is possible or not. So yeah, so we can use simply write a recursive code to do this thing. And after that we will try to memorize how we can memorize this thing. So yeah, so let's write the code for this thing. So we have something like we can make a function. So we have something like string and s, comma string and t, comma string and target. Yeah, these are the three types of string. And then we have something like I in j and k. And another thing we have was the two variable, like choose, like c, we can simply make it as choose one, comma we can make it as a bool, choose one, comma bool, choose two. So yeah, so like if at any point, like you can see the like body string length can be of different sizes. So we have also take care of this thing also. So we can say like if the k is going to equal the target dot size, it means that we have reached the last index. So in that case it means that we have find our answer, so we can simply return the one. So in else case we have to do like different types of things. So let's see. So what we can do, we can check like if the, so int n is going to be a s dot size, and int m is going to be a t dot size. So if the I is greater than equal to n, and similarly for j is greater than equal to m, so we can, in this case we can simply return 0. And else now we have to make all the combinations like that we have checked. So firstly we will check like if the I is less than n. So if I is less than n, then we can check this thing. So the first case is like if s of I, like if s of I value is going to equal the target of, so we can simply, instead of doing here in this, we can simply create another if condition in inside the another if condition. So now we can check if s of I is equal to target target of k. For this we have two options. So yeah, choose is going, like if we choose something like in choose is so choose is going to be a function of s comma t comma target. This thing remains same. So if we have choose this, we can move to next index I, and so we can simply make j remain same, and k also move to the next index, and choose one become true. So we can mark this as true, and the choose two become like it remains same as choose two. So not choose thing is like, so like if the s of I and target of k is not equal, so we have to do not choose thing in that case. So instead of writing in if condition, we can make it outside, so that it will run in both case. So s remains same, t remains same, target remains same. In that case, I plus we move to next index, j remains same, and also k remains same, and choose one remain choose one, and choose two remain choose two. So yeah, so we can simply define here the choose value to 0, and the not choose also to 0. So similarly we will check like yeah, we have to check for if the j is less than m. In that case also we have same condition like two condition. If t of I is equal to target of k, then we have something like choose going to become s comma t comma target I remains same, j plus 1 k plus 1, choose one remains same, and choose to become true, and like not choose is going to same also. Function of s comma t comma target comma I remain same, j plus 1 k remains same, choose one remain choose one, choose to remain choose two. So yeah, so like but we can have to add this thing like because like we have to write the overall the number of different ways. So yeah, so we can simply return the answer as choose plus not choose. So like you can see like the, since the answer can be very huge, we have to return its modulo, like 10 is to power 9 plus 7. So yeah, so like if we reach the target, we can't simply return one, so we also have to check two condition, whether like if the choose one is true, and the choose two should also be true. Like if the both are true, then we return one, else we return 0. So yeah, I think we can simply return the function of s comma t comma target, 0 comma 0 comma 0 comma false. Yeah, we can make it as s, and we can make it as a t. So let's try to run this. mm, Spelling mistake. Mm, oh my god, I am getting 30 as answer. So like if s of I, oh sorry, so it is going to be a t of j, I think this was the mistake. So let's see. So now I am getting um, if s of an st and target, st and a target, like if the k equal to target, then we are returning 1 0, yeah. If what the values are greater than equal to and like I is greater than equal to n and j less greater than equal to m, yeah, we are returning 0. So choose and non-choose. If I less than n, then if the s of I is equal to target of k, then we are going to choose it. In choose, s comma t remain as t target remains same, and I we move to next index, j remains same, and the k plus 1 move to k plus 1 index. So true become true, choose 1 become true, and choose 2 remain as choose 2, yeah, which is going to be false. Yeah, the value it can be true either or false. And not choose case, like s comma t comma target remains same, I move to the next index, j remains same, k remains same, choose 1 and choose 2 going to be same. Similarly for j less than m, I equal to, yeah, t of j equal to the target of k, choose equal to going to be s comma t comma target, I remain same, j plus 1 and k plus 1, choose 1 remain choose 1 and choose 2 become true. Yeah, this thing is also correct. Function s comma t comma target, I remain same, j plus 1 k, and we are getting overall, yeah, I think it should work. So yeah, let's debug this thing by taking like vector of vector t, and in this case like we are choosing, so we are going to add t dot push back, like which index we are taking. We are taking something like we can say ith index same and the kth index same of type 0, we can say, yeah. And we are going to t dot pop back. Yeah, it is going to become t of, instead of I, it is going to become j comma k, or from 0 it become 1, and we do t dot pop back. So now let's print this thing in case of when we are returning 1, return 1 for auto it comma t. Oh sorry, we can make it as a temp, because we already make taken the variable t as a string name. So yeah, for auto a comma it COT, it is going to be a temp. Same for this, same for this. Let's now debug this thing. uh, so I was I was 0 and again I was 0. Yeah, how is it even possible? Like what we are adding, we are adding I comma k. So yeah, so we are taking a from this yeah, a from 0, and a from 0 matches. Then we have something like, yeah, we can say something like this, like 0, 0, and then 0 from word 0, yeah, like this, word 0 0, word 1 0, word 2 0, and again the word 2, yeah, word 2 2. So it's like this this output. Then for 0 0, this 0 0 matches. Then something like 0 1. In this case we have taken 2 2 of 0. In this case we have taken 2 2 of 1. So like this, yeah, first two example. And then we have something like, again we get same answer, 0 0 0 0 1 1. How is it possible we are getting same answer, like we have only these things? Like you can see we are getting same thing again. So let's debug this, like like we are doing I plus every time, I plus every time, j plus every time, j plus every time. In this case k plus 1 here in first case, choose case, in choose case first, else it remains same. But yeah, but there may be possibility like we can reach to same thing, if we can reach to same thing by another like from here also, like in this case. So I think that's the trick in this question. So how we can do optimize this thing? So like, So like, is the increasing order must be maintained in both the cases, or itself only? The choose index from word I must be strictly increasing, and the choose index from word 2 must be strictly increasing at least one character. We can take A from here, then B or C from here. Like A from word 2 of 1, word 2 of A, yeah. And then word 1 of B, correct. And word 2 of C. A from first, B from first, and we can say, yeah, A from first, B from first, and C from second. So let's make it something like C here. We have to make A, C, E. A from here, C from here, E from here. So I think I have write something code something wrong, because for like A, B, C, D, E, A match, then this C will match, and this E will match. Like it will always be equal to, we can say, target dot size. So in that case we don't have log also. So what is this? Oh, sorry. So I have entered like a choose value there. I think now it should work. But again we are getting like again different combinations. Like from different states we are reaching same thing. So like instead of returning this thing at immediately, we can return this thing like whenever j is growing to equal to n, and also k is greater than equal to n. Let's see now if it's working. Again we are getting same thing. Oh sorry, I is greater than equal to n and j is greater than equal to m. Again we are getting 4 as answer. And we are getting, you can see, same indices, 1 2 3 4. How can we do optimize this thing? Like we can't choose something like this. So let's try to debug this thing. Like this problem, this is a small test case, so let's debug this thing. So yeah, so let's also copy paste this code. Uh, array dot. So yeah, so what we are doing, we are something like uh yes, 0 0 0 and 0, like all five values are going to be a 0. Then from here we move something like these values are same, so we do something like 1, it's going to be a 1, this is something like we can say I, this is j, this is k, this is choose 1, this is choose 2. So this is going to be j remain same 0, k become 1, and c1 become 1, c2 remain 0. From here what we can do now, like we have choose this thing, as if we don't choose this thing, we move to something like 1 0. So in this case, so yeah, it becomes 1, else all condition all will same will be a 0. So from here we can reach something like b, not b is not going to match, we can say it's going to be oh yeah. So like if we have something like 0 1, now we move this something I, it become 1 1 1 and 1 and 1, sorry, this will k will become 2, and then after e, like this e will match and this d will match. Let's say we get something like this answer. But now again, if we traverse from this way, let's say we choose something like from here we move to second, like 2 comma 0 comma 1, 1 1 0. From here again we reach to this same state here, like these states are same. Like in actually we can see like this thing, like this thing give this answer, and now again this thing also give this answer, something like this, like 2 comma we can take 1 2 1 1. So like the answer of this and both these thing are same. So we need to do something like, if we have skipped this thing, like if it is not choosing and its previous is also not choosing. How we can do this thing like now in an optimized way? So like this will be going to be a same answer. How we can track this thing? how we can do something like this, like this will, like this thing and this thing will give us the same answer, but we have to choose only one from this. We are in case of choose, we have option. So we are getting answer, a valid answer in case of choose only. If we choose something, we get this answer. So yeah, I don't think it will work. So let's try to do something like this. But how? What is the fun of doing that thing? So what can we do so that we can skip these things? Like if we have something like this thing, A, B, C. From here we can go 1 0 1 1 0. From here we can go something like 1 1 2 1 1. So 2 0 1 1 0. From here to we can go to 1 2 1 1. So in case of not choosing not, so we are also increasing the number also. Uh, two thing, two thing. If it is not choosing, if it is a not choosing thing, so like it's something like if we are taking like we are something like A B C. If we are taking A from here, and something like we can say, right, say example, right, we from choosing from here A and then getting some answer for that. And if we are not choosing to A, but we are moving to this B index, in that case A will remain same. Again for C, we move to C again, but we have used only A. So in this case, like both these are going to be a same answer only. Like both these thing will return to a same thing, because like in this case, like A is already, like we have something like A, we have A choose A. In this case, we have skipped like skip this B and skip this C also. So like in this all the three cases, from first only A is chosen. So how we can track this thing and maintain, like in that case you can simply skip this thing. Like if we have matching thing like that, if we have something like match, it's good to take. So if the A part is skipped, then we have something like A will, I is going to be a I J K C1 C2. I will going to move 1 and K will move to 1 and J remains same and chooses 1 comma 0. So from here if we move to something like I is 1, J is, so what we can do in case of skip, we can't like we can do alternative things. So let me, like something like that, int skip 1 and skip 2. We can make it as a boot on. So like this thing is, this thing must be true, and also then we can say like some, we have something like bool must be like a bool of skip 2, like skip 1 must be false. Like you can't do skip thing this thing in skip case, and similarly we can't do this thing in a skip of 2. And in this case skip is going to be a false and it is going to be a true, and it is going to be false, it is going to be a true, and in initially all are going to be a false. So let's see now. So yeah, so it is going to be a false, and skip 2 is going to be a skip 2. In case also skip 2 is going to be a skip 2, and skip 1 is going to be a, sorry, skip 1 is going to be skip 1, skip 1 is going to be a skip one. Let's try to run this thing. So we are getting 4 in this case. We have something like oh yeah. So I have also I have changed the test case for this thing. So yeah. So we are getting right answer. So yeah, let's try me let me submit this thing and then I will explain uh what I have done in this thing. What I have done in this code. And yeah. So firstly let's define the DP. I think now it may be a possibility this code will going to give us a TLE because we have something like this. Then 2 comma 2 comma 2 comma 2. It's going to be 100 cross 100 cross 100. I can say. So what are going to be 2 into 2 into 2 is uh, 2 into 100 into 100 into 100. So yeah, it tends to our 6, more than that, little bit more than that. Or I can simply make this as a dynamic also, yeah. So that for every case it is not going to be that big. So in that case, but we have to create a very nested vector of vector. So let's try to do this with simply a DP size of DP and DP of I comma j comma k comma uh, so here is going to be again one or two. Choose one, choose two, skip one, skip two. Choose one, choose two, skip one, skip two. Is going to be a something like this. So yeah, so we can say something like if uh, here we can simply write if this is not going to be a -1, so you can simply return this value. Yeah, so let's try to submit run this thing. Let me uh, choose two. Choose one. So yeah, so the DP state is working fine, I think. Let's try to submit this. Oh, I think I should remove this wrong answer for, oh yeah. So this value can be a very huge, so we have to uh, we have to return it modulo using ll equal to long and hashtag define what is the mod value 1e9 plus 7 1e9 plus 7 we can say something like that. So I think the code is working fine, so we don't need debugging thing anymore. So let's only comment this thing for a second. Yeah, so we can simply do like choose modulo mod, not choose modulo mod. Then again we can do simply a mod over this thing, and instead of doing this mod here again and again, we can make this at long. So yeah, I think now it should work. Let's see. We are getting compilation error. Return dp of a long double double. We are returning here. We can simply return here long as well. So what is the error? Long and a double. So 3, 4, 5, 6, 7, 8, and 7. So yeah, this is going to be like whenever we are storing in a DP, it is going to be a int range only. So let's again try to summarize this thing. So it's giving a TLE for hidden test cases. So how we can optimize it further? Is there anything we are missing? Or we can make something like vector of. But again, it's going to a very complex like a vector. How we can further optimize things? Something like we have, if we have skip 1 and skip 2, can we skip this thing? Can we skip this thing? Uh, yeah, let's do it for us. Some like this thing. Can we? Like there may be like yeah. If the skip is different, there the answer can be a different also. So we can't simply ignore this thing. Because we need like these three variables are like important to us, I, j, and a k, and this choose one and choose two are also important to track whether we have choose from both of this value or not. Let's again try to summon this thing. So yeah, let's simply convert this thing to a 6D array, because like if we are taking this 6D array, then like you can in small test cases also the value is going to be a 101 for that, so it's taking a lot of memory. I think we can, for that we can simply convert like mm, convert convert this to a vector. Let's say if it is able to convert this thing. So yeah, uh, so yeah, so now instead of doing something like this, we can do something like this. But again, so for that we have going to add -1, and for here are going to be n comma m comma k. We can say n+1, m+1, k+1, and then is going to be a s dot size, m is going to be a t dot size, and k is going to target dot size, and we can simply pass dp here. Okay, now again we have to pass it everywhere. So how we can pass this thing, also. Oh yeah, so we can simply pass this thing here also. Then something like dp here, and then dp here, dp here, dp here. So yeah, let's try to run this thing now. So let's try to submit this thing now. And now it is giving like TLE early. So I think there is no benefit of doing something like this. So let's import this code back, and let's see how we can optimize it further. Uh, how can we optimize it further? Like now the user acceptance was also quite high, like 2500. So it means that the problem is on easier side. So what can we do? So yeah, I think I will not further able to optimize this. So let me explain this thing. So yeah, after the contest we are going to see like another user code, and we'll try to yeah, try to see like how they optimize that thing. But I think like the uh so yeah, I can explain like this approach to you. So let me copy this code and generate us. So yeah, so the previous code in which what happened was like, so let me like I have tried on this on my notebook. So let's see. Let's take example from here only. So let's see the example only. So yeah, we have something example, some example like this. Yeah. So like if we add something like I, J, K, choose one, choose two. So like these are the five states previously we are maintaining. So like at like let's say we are like initially these all value are going to be a 0 0 0. Then if we choose something like let's say if we choose A from here, yeah, and A from A, like A from I, so it will look like since the I move by one, J remain zero, sorry, J remain zero, K move by one, and choose one become one, and choose two remain zero. Then from here we have option like something like we can skip this case, like we can skip this B. If we can skip this B, we move like our I become 2 0 1 1 0. Yeah, this case. So like from here, like now we can choose C from this and C from this. So we have something I remain 1, J become 1, and a K become 2, and choose 2 become also 1. So like from here you can see from this state we move to this state. But again from this state we can simply move to this again same this state. Like you can see. Like these state are same, like you can see like here is 2 but here is 1. So but in actual like you can see like this will game this will at and this will give us same answer, because we are skipping this thing like we are choosing A from S, and A from S here also, and then we have something like here uh we have C from T, and here also like at the end yeah, we have C from T. So you can see like at the end these like we are only choosing A from S and a C from T. So like this will give us a same thing. So what I do next to do like, so that like if we are going to skip this thing, if we are going to skip this thing like let's say we choose the like we choose this A value, then we will calculate we have option to check for different ways, like we can skip C or choose C like that. But if we skip this K like B, then this A part, this answer, and this like if we choose this answer, this going to give us the same answer. So we choose only A for A part, like whenever we choose this thing we have option to choose like different option for B. If we don't choose this, we don't have option to explore the B part. So yeah, so I am doing something like that, like maintaining two variables, skip one and skip two. So like initially both value of skip one and skip two are going to be false. So I am checking like if is less than n and the skip one is also false. Like if this skip two, in case of as I am checking if the skip two is false, it means that we have choose the previous value from T. So if we have chosen that value, so now we can explore different ways for to choose the string from S. So like if I choose as from like if I choose like if the value are same, and if I choose, in that case I am making you can see like making the choose one as a false, and sorry, skip one as false, and skip two will remain same. And if I don't choose, I am making the skip one as true. So like if this skip one is true, we can't we will not we will not going to explore the path for the target T, for sorry, string T. So yeah, this is the main idea behind this, but somehow it is not like the code not pass that test cases. So yeah, so now the contest is over. So let's see, let's try to see some solutions of this problem, and then compare it with our solution. So why was our solution was not working? So yeah, let's see. Why lead code is not working? So why is it not sorting the questions by question ID? Let's again do this thing. So yeah, so let's open this. So yeah, let's is it it is not opening. So let's try to give this to a chat GPT and ask it to optimize this code. So yeah, can you please help me to optimize this code and properly explain the pros from first principles, so background. So yeah, let's generate, let ChatGPT generate these solutions for that. So yeah, I think the lead code side is down. So what does your state represent? Like I is yeah, I current index of S, J is current index of T, and current index of target. Choose one, choose two. Have we chosen at least one character from? Yeah, you can see it's going to be a 16.5 million. Yeah, which is already huge. Does every variable really affect future decision? This is the main important DP optimization question. Yeah, so I think from something I know, like I think like all the things are important from my understanding, I think. So let's see what ChatGPT observe. K, where you choose a character k equal to k equal to k plus 1, the choose character from the prefix of target. So like uh, can we calculate this thing by k taken from s equal to something, taken from t is equal to something, and k is going to be a taken from s and a taken from t. So often in interleaving problem, k equal to I plus j. Yeah, so whenever you see three indexes, can one be driven from another? True. So remove one dimension. So let's say, can we do something like, so it gives us a hint. So let's see, but I think of this also, but I don't think we can optimize this, optimize anything in it. Mm. So let's see what other examples. Skip one and skip. These flags are Suspicious. Skip 1 true. I already decided to stop taking from S. Skip 2. I already decided to stop from T. This is not really current state. It's more like which string am I currently allowed to use. Instead of skip 1 and skip 2, can use both. So last taken depending on exact problem to choose it. Examine choose one and choose two. How we can choose as one? Yeah. State compression. So we like in this case we can't we need I need J is required, K is required. So we have only these four. Like if we can optimize even one of this thing, I think like we are good to go. So you can compress something like mask comma state. So like if we are going to take 2 comma 2 comma 2 comma 2 is going to be a 16. But if we are going to take 3 comma 3, so it's going to a 9. So I think uh, so yeah, I think it's also a it also do something optimization like this. So instead of taking this two, it is taking something like we are taking 2 comma 2 comma 2 comma 2, it's going to take 4 comma 3. So already smaller. Can K be removed? This is the next question. K is the match character so far. Can it driven from IJ? So I think no. I think no, it can't be driven from IJ. General DP checklist. Whenever you see a large DP state, so it's giving some suggestions. Can multiple boolean become a mask? So what is mask like? Let's again see. Explain skip one, skip two. What? Where is mask? Uh, I already decided to stop taking from T. This is not really good. Can use both. So can we use both? One equal to only S and two equal to only T. Vi- वीडियो रिकॉर्ड कर रहा हूँ. So yeah, so I think let's see the solution of any other guy who has solved this fourth problem. So yeah, this is the problem. So let's see. So yeah, so I think like I can stop. I will solve this later and will try to understand how we can optimize this thing, and then I will make another video for this. So yeah, so that's it for today. So let's stop this video. Yeah.